Okay. Hi, everybody. This lecture today is an introduction to scikit-learn or sklearn library. sklearn library was developed by a specialist working at Google. Nowadays, it is an open source library, and you can install it by using anaconda.org. There you can install sklearn and also skimage. This is a very huge library with many classes and methods and datasets which are used in order to carry out linear or nonlinear regression and classification and many other machine learning activities. It is considered as one of the most common libraries in machine learning. Lastly, in France, the TDF, Technologies de France group, has also developed a sub-library through which you can use different developed virtual instruments, and by this you can use sklearn directly with LabVIEW also. This is also an advantage. sklearn includes a comparatively large number of datasets, which also could be used to carry out regression and classification problems. Here you see you can use sklearn library and import the datasets which are included there. You download all the datasets as you see here, and then you print it, and you will come up with this number of different datasets. Some of these datasets is small with a limited number of samples, about 400 or 1,000, and some of them include a large number of samples. An example, Fitch California housing, for example, where it includes about 20,600 samples. Some of these datasets is very common also and famous and used frequently to explore the different techniques when working with machine learning. An example is the load iris dataset here, or load digits dataset here, load diabetes. They are all very known to specialists and very commonly used. One interesting dataset also is the make-plops dataset, which is used to create a dataset synthetic dataset, which could be used for classification purposes, and also make regression, where it is yes, here it is make regression dataset, which is used also to generate synthetic data to be used for regression purposes. Anyhow, you can learn about any of these datasets by using the description function or information function, which gives you the statistical and other necessary information about each of them. I am talking about these datasets because we shall use some of them in our work. So now you have an idea what is sklearn and the datasets included there. An interesting specification for all these datasets that they are designed by sklearn as a data structure which is called bunch, as a bunch. A bunch generally is a dictionary-like structure where you can call the elements, the objects, by using the notation, the dot notation. But also you can use the data frame assigning by using quadratic brackets. Using the dot notation makes the things more simple to use and easier. We shall anyhow work with both of them, and we shall also convert the bunch data to a data frame data work or data frame. Yes. So I think this is the most important brief information about the sklearn. Let us go through some examples to understand the different techniques which are used there. So again, a bunch is an object in scikit-learn or sklearn, it's the same. It is a dictionary-like object which extends the standard Python dictionaries. Yes. And here it is also emphasized that it allows all the accessing the elements or the object as a dictionary key. As you see here, you write the name of the dataset, and between quadratic brackets here, you assign the name, or as an attribute by using the dot notation. You write dataset, the name of the dataset, then dot, and then the name of the attribute. And you will access it directly. Here is a briefing of the objects which could be used as attributes for the data sets in sklearn. The first one is the data, which is a NumPy array of a shape with a number, two-directional array with number of samples n represents the arrows and the number of features which represents the columns. This data holds the values of the features. The other attribute is the target, which is an NumPy array of a shape n samples only, and it holds the values of the target or targets if there are more than one. The third attribute is this from description, the shortened DESCR, which is a string containing a full description of the dataset. You can also use, in addition to description, you can also use the information function, info, followed by brackets. The other attributes, feature names, which is a list of strings giving all the names of the features of the columns, and the target names, which is a list also which gives the names of the targets if there are more than one, or the target which is main of interest. So these four attributes are very often used in working with the sklearn datasets. Let us begin through examples discussing these specifications and how they are applied on specific datasets. Let us work, for example, with the iris dataset. So in order to load the iris dataset, you call the datasets and followed by calling .load iris function. Load iris function. You assign the values which are included here to an object variable. You call it whatever you like. Here it is called, for example, dataset, not datasets, but dataset. Now this dataset is the bunch. This is a bunch, and this is not a framework, a data framework, structure, or in a data form, data frame, DF. So data set now here is a bunch. Now, in order to know, to be sure what is the type of the data set, you can use the function isInstance. You use isInstance function with between two brackets and pass there the name of the data set which you are interested with, and then pandas data frame to be sure that this instance is a data frame or not. So you write print instance isInstance data set a data frame. Here it is read like this. Is the instance data set, which is here, is a data frame? The answer, of course, will be a logic output, false or true. It will be, of course, false. If you go downwards, you will see here it is written as a false. This is not a data frame. This is a bunch. So to check if the data set is a data frame, we can use the isInstance function. Of course, we can also print some values because the data set of iris itself is about 400 samples here. We are not interested to see all the values. We can see a specific number. For example, here I am asking the program to show only the first 5 samples from 0 to 4. Dataset, look here, dot data. So here we are using the dot annotation to access the values which are within the data, which are the values of the features of the data set. So if we print this and go down, we shall see here is the data. As you see, 0, 1, 2, 3, 4, not 5, as I mentioned, 4 rows, and the output, the data here is arranged as a 2-dimensional NumPy array. Within the data set, it is arranged as a 2-dimensional NumPy array, and you can access it by using dot data with the given number of arrows of rows which you want to see. Similarly, also we can call the target or targets if there are more than one. And here also we can find the values of the associated with this target. Here the first 4, 0, 0, 0, 0. There are, in this data set, here we have a target of 0, target of 1, target of 3, and 2. If you look at them downwards, I have the here. Here is the complete target values. We shall see it now. Here at the beginning, you see the first one is 0, the second 0, the third 0, and it continues up to this number here. This index now becomes 1, 1, 1, and this 2, 2. So we have 0, 1, 2, only 3 target values, which is really common for classification purposes in machine learning. So now we have called the attribute target by using the dot also and printed the first 4 values. Also, the feature names are called in the same manner. The dataset itself followed by a dot, which gives the feature names. And also the dataset followed by a dot target, but here remember target names you write, not target name. Even if you have only one target, you have to print target names. And the last attribute, which could be also called by using dot notation, is the dataset dot description or describe, DESCR. Let us have a look at them. So the feature names, as you see, they are given as a list string of strings. One of them, the sepal length, sepal width, petal length, and petal width. 4 values here. And the target names, as you have seen, there 0, 1, 2, 3 values. The name of the first one, which is the 0, Cytosa. The second name is versicolor, and the third one is virginica. These are the 3 names given as target for the targets. That description, as you see here, really you have a lot of information which describes the data. As you see, it talks about the classes which we have there, the three classes, iris, for example, setosa or versicolor or virginica, the attributes, names, or information, length and width, and the sepal and then the petal also. Here also we have some statistical information about the sepal length and sepal width and petal length and petal width as the minimum, maximum, mean, standard deviation, and class correlations, and also other more interesting information about this data set. Really, it is advisable here always to have an idea about the content of the data set and what does this data set represent and what are the basic components of this data set to be a little bit familiar with it before working in regression or classification targets. Yes. Okay, now we are here. Convert data set to a data frame. So again, you can call the data which is included in the data set and assign it to the variable data of the data frame. And the same thing, you can call the names of the feature names included in the data set and assign them to the columns. So the data frame now has a data values and have the columns, and then you can have a data frame, DF. This is done through the function pandas pd dot data frame function, and you pass these values in. After that, we get the diff. Of course, it is obvious for us that it is a data frame, but to be sure also we can use isInstance function. So isInstance data if is a data frame, the answer will be true. If you go downwards, here it is true. It is given as a true. So now we are sure that we have converted from the bunch structure to the data frame structure as upon request, as you wish. And again now, you can work with this DF as a traditional data frame. For example, DF head of the first four, but of course you can call head without values here. It will give you the first 5 values, or you can insert here the number which you wish, 3 or 4 or 10, whatever the number of rows you want to check. So now here we have printed the DF head, but only for the first 4 rows. If you go downwards, here this is the DF head, and this is the first row, second, third, fourth rows. And here, as you see, it is a complete sepal length, sepal width, sepal length, petal width. All of them are existing with their values, with the values of them. Yes. Of course, if you are interested to see all the values of the data frame, you have to print the data frame complete. Only print data frame without extracting the first 4 or 5 rows. And in this case, you will get the total number here. As you see, it begins from 0 and continues to the first 5, and then it gives dots so as not to repeat or to type all the values, and shows you the last one here. Okay, so I think this is done. Yes, this is the data frame which we have got by assigning only the first 4 rows, and this is the data frame which is complete. I called it all data values. Also here I have printed or assigned sepal length in centimeters. I want to have the values of the sepal length attribute. Here, if you go and you see the values here is the sepal length attribute. If you want to see only the values of this, so you have them here. Sepal length values beginning from 5.1, 4.9, and you continue downwards up to the end. Here we have selected only one column and checked the values of that column only. Why? Because maybe we are interested with it, and that's it. Okay, so we are here optionally add the target column. If you want to add the target column also, so from iris you call the target. Here the values which are in the target are assigned to the DF frame. And now we will have a complete frame with the features, and which are the first 4 features, and added to them the last column which represents the target. So what it is called here by me, it is called complete. Yes. So if we go down here, the complete, and now these are the values 0, 1, and 2, as you see here. This is the complete target values for all the values in the data frame. Okay. The last thing also, I am trying to illustrate to you to print the data frame without column names. And suppose we want this for the first 4 rows. So I want, as you see here, these 4 rows, 0, 1, 2, 3, I want to have them with these values, but without these names. Sometimes you need that, and this is the technique how you do it. I used the data frame itself. I extracted from the data frame the first 4 rows. Then by using a dot notation, I converted it to string and passed to this string header equal to false and index equal to false. No headers, no indexes, only the pure values. If you run this, I assigned it to a variable called Ali. If you go downwards and see Ali, for example, this is Ali. Here the values, but there is nothing here as names. There is no column names and no indexes here from 0 to 1, 2, 3, 4, or so on. So without indexes, without feature names, only the data, and for only the first 4 rows. Well, this is, I think, the most important techniques you may need. At the end also, I have used the data frame case. I called the case from the data frame, Here you have the names of the case. And maybe also you can use the same data frame with dot columns and you get the names also. Here, the names are here: sepal length, sepal width, petal length, petal width. At the end, you will get only these names here. So sepal length, sepal width, petal length, and petal width, as you see, and also sepal length, sepal width, petal width with the target. So it depends what do you want, but as I think most of the interesting techniques which could be used by the bunch and the data frame now are illustrated to you, and you can refer to this example when you want. But this is not really the only interesting thing I am showing you today. I will show you also other interesting works, techniques related to the bunch of the scalar. So here we are going to another example, and we shall use the data set which is called make regression. If we go backwards, I have noted before that we have a data set called make regression. Make, where it is, make regression. Here it is, make regression. With this function, you can create synthetic data sets specifically to carry out linear regression. This is applicable for one feature or multi-feature applications. So let us see how we do it. At first, we have to import the necessary libraries which we want, or datasets. We import NumPy as NP. From sklearn, a linear model, we import linear regression. We are going to carry out linear regression on the dataset, which we will create. And now we also, from sklearn datasets, we import make regression. With this make regression now, we can create data which will be used for regression purposes. So, as a beginning, as we do with sklearn, the data which we have, we split it to training and testing sections. So we import train, test, split function from the model selection. And the model selection, this is a model, exists in sklearn. This will be used very often by you. So again, from the sklearn, we call model selection and import from there the function train test split. Usually, we do this so that the data will be divided to a training part. The data which we have will be divided to different sections, 3 sections. One section which is going to be used to train the model on it, and the other will be used to test the performance of the model, and the third one, which is really used to examine the behavior and the score of the regression process by using additional data which is not included anywhere. Okay, in order to carry out some plotting, we need matplotlib. We know this before. And because we have to use NumPy and this is a random process. We need, if we need to repeat the same values for every new run, we have to fix the random state. I usually use number 42, and I think I have explained to you why to use 42 before. So up to now, we have imported the necessary libraries and functions which are going to be used. The new thing here for you is make regression. This is the data set and function which is going to be used. Thus, we have the make regression here. We pass to this function the number of samples which we want, number of features which we need, here one, so that to have something similar to real life, the data set will be with some added noise with a given level equal to 5 here. And if you want the regression process to give you at the end the value of the slope when you have a linear regression, you require the coefficient, so you print coefficient. This is the coefficient, which is the slope, so it is coefficient equal true. And here again, random state equal to 42, so that to guarantee repeatability of the output value for different runs. This make regression data set, which is organized now, when run, it will give you a values of features X, values of the target or targets Y, and the coefficient which represents the slope. Now let us try and print X and Y. This is the values which we will use to make regression, the features and the target. Let us print X first 4 rows and first 5 values of the target. If we go down and see them, here is X. You will see X is a 2-dimensional NumPy array. These are the first 4 values of it. And these are the values of the Y, which is the target values. There are 5 because I have asked to show 5 just to show them differently. And if I print coefficient, if I run the program, I shall get coefficient equal to this number, which represents the slope of the linear regression. There will be a line which represents linear regression function or plot, and the slope will be 14. We shall see now also that we can get this slope by regression function. So suppose that now we have X and now we have Y, and we want to make regression activity on this data set. We have called linear regression previously here. Linear regression already is called. So this function now is assigned to a variable, which is the model, called a model. And this model now is fitted to this X and Y. So now this is the process of learning X and Y is shown here. The learning has finished now, and now you can use the model and call from this model the intercept, and then we shall see the intercept value, and if we print it, we shall have a value. And also we can call the model, and from the model call the coefficient, and we shall get the slope. The slope which we get here or we get directly by printing only coefficient will be exactly the same. So as you see here, the intercept coefficient, the value of the linear regression line when x equal to 0 is, this is the value. If you look here somewhere, it will be about 0. If you now we will run maybe the linear regression line, and it will be about how much? About minus about 1, about 1. It will be about 1. It be practically about, if here is minus 30, minus 20, here minus 10. So in this level, it will be like this from here, for example. It will go like this. Okay. And these are also the values of the, the values of the slope. 14.7 here, 14.09, practically the same values. So what we have done, we have created the x and y values. This is their features values for all the columns. This is the target column. We have applied make regression so that to create these values, and then after having them, we use the linear regression model to read these values, to study these values, and come up with the intercept and with the coefficient values. Now, this is done completely now, as we did, for example, with SciPy before. But if you want to plot the linear regression and to see, we shall use, of course, the matplotlib. And for this purpose here, I have already divided the data to 3 sections: train, test, split function, between brackets. The first portion will be the x, the other one will be y, and the third one which will be used for testing. Normally, as a common practice, the testing portion will be about 20 to 30% of the whole data set. So if the whole data set, for example, is 90 rows, so 30 rows will be used for testing, and the other 60 will be used for training. So as a result of this function, now we have these portions: x train, x test, y train, and y test. Having now x train, we shall use the model to predict the x train values, and to predict a value for each x test value, and it will give you a y predict value. So y predict here is a number of values relative to each value of x test. Knowing x test and knowing y predict, we can draw or plot a line which represents the prediction line, the regression line. Let me take away these primes so that to include this piece of code in the program. Now they are included in the program. If I run the program now, I shall have the linear regression. Now it is finished. Here the data set, as you see, it was before, and this is the linear regression appearing, and really it begins at a level of equal about 1 here. 0.8. This is the linear. Of course, we can extend it if we want. So this is the linear regression applied to this synthetic data set, which are red dots here, which was created by make regression. Of course, in scikit-learn, there are many ways to make regression. And one of these ways is to use a specific algorithm called SVR, support vector regression. It is really derived from support vector machine learning, and it is also used very often, and I shall work on it with you maybe in the coming lecture or within 2 lectures. So what we are going also to do, we shall introduce this piece of code to the program and to see the result of linear regression, either by using linear regression or by using SVR, support vector regression. But when using support vector regression, you have to specify the kernel, which the kernel is an algorithm. The kernel which you are going to use. Here we shall use a linear, because this data set is generally used for linear regression. And the other reason is to compare the result which we have achieved before with the result which we will achieve by using SVR. So here SVR algorithm or function, we pass there, we define there the kernel which will be linear. Of course, it could be linear, it could be RBT, it could be another type as polynomial, as you want. See, here is a coefficient, and this doesn't matter the result. So now, after assigning the linear function here, we have SVR, the model itself, or the optimizer, the estimator, is called SVR, or given a name SVR linear, LIN. And now this is applied to our data set. So SVR linear dot fit xy. Now it is learning the given xy, and we predict the x values. We predict the output for each of the x values, and this will be called y linear. This is analog as y predict, but here I gave it a name y linear. And now if you plot it, x as the abscisse and y as the ordinate, and give it a color, and you will see now a new figure overlaid on the previous one. If we run the program now, as you see, this is the previous in green, which was realized by using linear regression, and this is the SVR linear regression by using the SVR algorithm. Really, I have given you this example just to introduce to you in advance the concept of SVR, the algorithm of SVR, and to compare both results to be sure how they work on the artificial or the synthetic data set which we created by using make regression. Okay. Now this is the second example. Let us move to another example today, how we can use the make regression to have 2 features, 2 targets instead of one of them. Really, there is no problem with that. This is done as we did before, but only by changing the number of the features. So we import data set and make regression from it. We make regression from the data sets of sklearn. In order to plot here, I have used matplotlib and NumPy library to work with NumPy arrays. So make regression now is used. We pass to the make regression the number of samples, suppose there are 200. Number of features, now we have 2. Number of informative features, here really, usually when working with features, there is something in machine learning called feature engineering or feature analysis, where you select the most influential, most interesting features to be included. Here we are using the same number 2, the number of features, both of them are influential and informative. They are used here. Of course, we can work without this. Noise level is given as 15. The random state, as usual, we have given it 42. And yes, we want to have at the output also the value of the coefficient, which represents the slope. So practically the elements which are passed to the make regression are the same, but with different values. Now we have just created X and Y, but we did not carry out any work here. The shape of X and the shape of Y here, X and Y, of course, X, as you have seen before, it is a two-dimensional array. So it will have two values. One represents the rows and the other value represents the columns. Y, it has only one value which represents the rows. So if you look at the shape, you will have X shape is 200 by 2, because two features, we have two columns here. Two features, we have two columns, and 200 is the number of samples, which is here. So the shape is 200 by 2. Y is 200 only, and that's it. Now, if we want to see the data set which we have created a data set X and Y. So, as usual, we can create a data set using three-dimensional coordinates. So at first we create a figure, PLT figure size, and then we have to create a three-dimensional axis, figure add subplot 1, 1, 1, projection equal 3D. 1, 1, 1 here means that the figure will be given in a one array, one row, one column, and the last one represents only, we will have only one figure. And now we want to print this in a three-dimensional space. The first X of 0, which represents X1, the other one X of 1, which represents X2, and Y, which represents Z. So we have three coordinates, X of 0, X of 1, and Y. We have given it a color red, and we can now print it. And we shall see now, this is the data set which we have created as a three-dimensional, in a three-dimensional space. Of course, you can change numbers, you can change whatever you want. Suppose you want, instead of 200, 500. And the shape, let us be 12 with 8, for example, here. This is which we can change. And now, if we run it again, we shall have some, as you see, some difference by changing some values. So now we have used, as you see, the create or make regression with two feature columns, and we have plotted it now, not as this one as in XY, but in XYZ space. as a three-dimensional data set. Let me also show you this short example. We have imported NumPy library and pandas as PD, and we have imported the bunch from sklearn. How you do it? From sklearn dot utils, from the utilities, import bunch. Now the bunch as a function exists. Here I have did it to show you the similarity between the data frame and the bunch. So if we want to create a bunch, now we have the bunch with us. So bunch function, and we pass here the name as the K in the data frame. It is given, for example, a name Alice, the age, this is the K, this is the value of the K, city is the K, New York is the value of the K here. And now if we print the data, so we will have it, as you see, as if it is a dictionary with a name as a K, this is a value, age is a K, this is a value, city is a K, this is a value. Okay, now, access values using attribute style access. When working with bunch, as I told you, we can access the values by using the dot attribute or by using dictionary style access. So for this case, for example, data, we have data now, here it is created, data dot name, now I shall get Alice. I shall get the value of this K. So when I print data dot age, I shall get the value of the K, which is called age. So here I shall get Alice, here I shall get 55. So as you see here, we are accessing the values, the data of the names of the features, name and age, by using a dot notation. But we can do also, we can get the same by using dictionary style access. Here is the data, here is the brackets. We assign the K which we want, name or city, and we can get also exactly from the name we can get Alice, and from the city we can get New York. And the last thing I want to show you here is also you can assign a value to a given K. So for example, here 77 will be assigned as a value to the age value attribute of the data. So when you print this, you will get not 55, you will get the new value 77. Okay, really, I feel that it is enough today to give you time to repeat and study this material slowly to master these techniques which I have emphasized. And in the coming lecture, also we shall work on practically the same activities, but using a more complicated data set, which is called California housing or Fitch California housing data set. We shall describe it in the next lecture, and we shall try to understand how we will manage operations on this as a bunch and as a data frame, and we shall carry out also regression on it as we did before. And until then, wishing you the best and goodbye.